Today I'll really be talking about vector search and more broadly vector databases as well. So I think if any of the folks here are familiar with LLMs, and in particular a concept called retrieval augmented generation, you're probably familiar with vector databases as well. But what folks don't know is that vector databases are useful for more than just LLMs. They're useful in a variety of different applications, which hopefully by the end of this presentation, you'll be able to understand a little bit better, and you'll be able to understand these are many of the different ways that vector search can be used and why it's important for your business. So a bit about me first of all. Hey everybody, my name is Frank, Director of Operations, ML Architect at Zilliz. And if you want to get in touch with me, if you're interested in, let's say, talking about anything ML related, about vector databases or about vector search more broadly, feel free to get in touch with me there. And a bit of a about what I'll be talking about in this presentation first, right? So I'll talk a bit about us as a company first. I'll talk about Zilliz. I'll talk about vector search, and I'll give an introduction to vector search and why vector search is important, what are the different ways with which it can be used, and how that is relevant to a vector database as well. I'll then dive into vector databases plus LLMs, I know everybody's favorite topic today, and then I'll talk more about beyond generative AI. I'll talk about some of the use cases that we see as a part of the Milvus open source community and how vector search is really driving forward a lot of the ways that AI ML can be used today. So first things first, a bit about us, about Zilliz. We are a company based in sunny San Francisco Bay Area. We were founded in 2017, and we are the company that is behind the open source project Milvus. How many of you have heard of Milvus before? Okay, all right, so a couple of hands. And Milvus is the world's most popular open source vector database, right? And my hope is that by the end of this presentation, everybody's going to be familiar with what a vector database is, everybody's going to understand what Milvus is good for, and hopefully you all will go download it as well. I also want to spend a little bit of time before I dive into the rest of the presentation talking about the Zilliz Cloud platform, right? And Zilliz Cloud in particular it is a vector database, yes, but more than just a vector database, it is for all sorts of unstructured data processing. So if I have images, documents, audio, or other UGC, what I can do is I can take those, store them into Zilliz Cloud as a hosted Milvus vector database, and then I can have a lot of consumers, I can query across all of that data, and I can build and extract a lot of insights from it, right? On top of that, we have a variety of integrations as well. So integrating with a lot of LLM providers, with AWS GCP, and then we have Azure and Ali Cloud coming a little bit later this year as well. So vector search, right? What is vector search? What is it good for? And how do we actually use it in production? The first thing that I want to talk a bit about is the vector search or the vector embedding workflow. Now, on the left you see it could be a knowledge base, yes, but it could be any type of unstructured data as well. Images, video, audio, text. And a key concept here to remember is that when we pass them through a lot of these deep neural networks or these deep learning models, the output representation for those pieces of data is vectors, right? Whereas I'm communicating to a lot of the folks here in English, vectors are the words that computers use to communicate with each other, and machine learning models are their language. That's one of my favorite analogies to use. Now, once we have these vectors, what do we do with them, right? How do we make sure that we can extract all the insights out of these vectors that we can? Is you store them inside of a vector database, and you do what is called approximate nearest neighbor search. Now, the key idea here to remember is that vectors that are closer to each other in this high-dimensional space, now these vectors could vary anywhere between 128 and 192, all the way up to over 10,000 dimensions, I've seen from some OpenAI embeddings, is that vectors that are closer to each other in this high-dimensional space correspond to pieces of input data that are more similar as well. So here on the left, this is actually taken from Eric Byrne's slides a couple years back in the NYC ML meetup. And over here on the left, this is from the MNIST data set, we have query images. And specifically, what are we querying inside of our vector database is the vector representation of these digit images. This is from the MNIST data set. And over there in the middle and on the right, you can see the results from my vector database, the results of this vector search. I think this is using LeNet5. And in particular, I want to draw your attention to that bottom row, right? Is that digit on the left, my query digit, is that a 0 or is that a 6? Well, no. And the vectors, the embeddings that are generated from this trained ML model really encode all of that information. And this is a property that this is what vector databases use to generate all the insights that you see on that previous slide a couple of slides ago, right? This is why vector databases are so powerful. And it looks like I'm missing an image here. I apologize about that for everybody. I don't know what happened to that, but there's supposed to be a picture of food here as well. I apologize. I'm happy to share this with everybody at the end of the presentation. Looks like we had a bit of a hiccup here in transforming it to a PDF. But there's also ways to do this that leverage other forms of unstructured data, and words and other pieces of natural language are a great example of that. This will tie in very, very well with the next section when I talk about vector databases plus LLMs. In this particular instance here, this is from the TensorFlow projector, and this is a very, very old word embedding model. This is word to vec. And you can see how a lot of these small clusters sort of pop up. At the very bottom, I see a lot of names. Over to the right, I see scientific processes, and over at the very top, I see things related to biology, biological sciences, right? And this is the power of embeddings. I hope this is getting everybody here excited about what embeddings are good for and why vector search is so powerful. Beyond just searching for nearest neighbors, you can also do what is called vector arithmetic. Some of you have probably seen this. Many of you probably have. But the idea that you can subtract, you can add vectors from each other, and you can get really, really key semantic meaning. So in this case, you see how queen and king are correlated and how man and woman are correlated as well. And this is from 2 different trained word embedding models. So you see in both cases, I've preserved that semantic meaning between these 2 words. This is what makes, again, vector search so powerful. So now that I understand a little bit more, now that we understand, a little bit more about embeddings, and in particular how these embeddings are generated, I want to talk more about similarity search. Now on the left, again, we have a variety of different types of unstructured data, right? These pieces of unstructured data could be from a variety of different modalities: images, video, documents, and audio. And I transform them into these embeddings. I transform them into these vectors, and I store them in a vector database. And then that vector database, using an index built across all of that data, is going to do that approximate nearest neighbor search for me, and it's going to be able to pull out all of those insights that I was talking about a little bit earlier. But I think this also begs a question: why don't I just use a traditional database for all of this, right? Why do I have to use a purpose-built vector database? And the answer to this, I'm not going to go over all these individual bullet points, but the answer to this is that traditional databases, relational databases, NoSQL databases, they are not built from the ground up to support vectors. Vectors are not first-class citizens in these different types of databases. And if you go to our website, we do a lot of benchmarks with other vector databases, and Elastic is one of the ones, Elasticsearch is one of the ones that we do another benchmark against. And you'll see that Elastic, the performance is much, much worse than any purpose-built vector database out there, and that includes both Milvus and Zilliz. Now, is that because Elastic has crappy engineers? Excuse my French. But is it because they have crappy engineers? No, right? It's because Elasticsearch, Lucene, is not built from the ground up to support those vectors, right? This is the message I want to deliver to everybody here today with this slide. So what is a vector database? I feel like I've sort of come full circle here. What is a vector database, and how is vector search really a key part of this? A vector database, in addition to providing you with high-performance vector search, it can do things like advanced filtering, metadata filtering, scalar filtering. You get hybrid search, where you get dense plus sparse. You get a lot of durability, replication, sharding, a lot of features that you would want in a traditional RDBMS or a legacy RDBMS you get in a vector database as well. And this is what is so great about vector databases, such as Milvus, such as Zilliz, is it takes away a lot of that infrastructure component from your vector search application. I'm not going to spend too long on this slide. Happy to chat about this a little bit more after this presentation for anybody who's interested. But this is the architecture of the open source vector database that we have built at Zilliz called Milvus. And in particular, I want to draw your attention to the lower 2 layers, right? So at the very bottom, we have object storage, and then we have all these worker nodes. So not only in this particular vector database, in Milvus, do we have separation of storage and compute, but we also have separation of different types of compute as well. You can see over there, my query nodes are separated from my data nodes, which are separated from my index nodes as well. And that is what makes Milvus the world's most advanced vector database. That is what makes us so powerful. Okay. Now, again, I won't dive too much into some of the details, especially stuff with the write-ahead log, the message storage, and the coordinator service, but if anybody is interested in talking about this a little bit more, I'm happy to dive into more details after the talk. vector databases and LLMs. So I think this definitely warrants a bit of a conversation. And this particular workflow is called retrieval augmented generation. Anybody heard of that, RAG? Okay, so good number of hands as well. And the idea with an LLM, let's say something like ChatGPT or GPT-4, Bard, Claude, MPT, and any of these other open source LLMs is that they are not trained on private data. Well, I mean, I hope they're not, right? If you have private data, let's say, in your organization, if I'm a big financial institution or I'm a legal firm, hopefully I have data that didn't get leaked to ChatGPT, that didn't get leaked to GPT-4, and it wasn't trained across that data. But I still want these LLMs to be able to answer questions, able to have that type of context. If I ask ChatGPT, let's say, what are my Q3 earnings, and I'm a big financial institution, I want the LLM to be able to respond, to have that context and be able to respond with a proper response. And this is the retrieval augmented generation stack. Essentially what I'm doing is I'm taking a prompt and a query. The prompt and query in this case are the same thing. And I first will search my knowledge source, in this case a vector database, for the most relevant information, right? I'll take that information and then I will inject that into my LLM as context, as a part of the context window. Now what does that give me? It gives me the capability to tell my LLM, here's the information that I want, and here's where the information is stored. Go generate some insights for me, right? Go do what you do best as an LLM, which is reasoning. Right? Go do what you do best as an LLM, which is picking out the information that I need and putting it all together in a human readable form. That is the power of retrieval augmented generation, and that is why vector databases are so popular with LLMs today. We have our own version of RAG called CVP, and in this case, C is ChatGPT, V is vector database, and P is prompt as code. And we have a great demo of the CVP framework, again, our own version of RAG, called OSS Chat. Now, what is OSS Chat? I'll describe it very, very briefly. It's essentially a way for you to chat with open source projects. The way that we've structured OSS Chat is very, very similar to this previous diagram that I showed up there, and the next diagram that I'll show as well. And in particular, OSS Chat allows you, it indexes documentation for a lot of open source projects, and it allows you to answer questions about those documents as if it was just regular ChatGPT, right? One of my favorite things to actually prompt OSS Chat with is I like to ask it, how do I query in Milvus? Milvus being a database. If you ask stock ChatGPT, it actually gives you the wrong answer. It hallucinates. But if you ask OSS Chat, it will pull from the relevant data sources, and it will give you the correct answer. So I encourage everybody to try that out on osschat.io. How do I in Milvus? And try that out on ChatGPT as well, or on GPT-4, and you'll see the difference. And that is the power of CVP. That is the power of retrieval augmented generation. Again, I'll go through a bit of the architecture here of how it works, and hopefully this will give you a better idea of how you might be able to build your own CVP stack or your own retrieval augmented generation project, application. The first is OSS Chat will take project information from GitHub, as documentation, or from the website as well, and it will convert all of those into vectors and store them inside of Zilliz Cloud. Zilliz Cloud being the vector database that we have built on top of Milvus. And then from there, it will actually generate relevant, when a prompt comes, it will actually find relevant documents inside of Zilliz Cloud and inject those as context into ChatGPT. Now there's one area that I'd like to direct your attention to, or one box I'd like to direct your attention to in this slide that wasn't present in previous slides, and that is over to the bottom right. We also have a project called GPT Cache. I think hopefully this name is pretty self-explanatory. It serves as a caching layer for GPT responses and other autoregressive or generative models. And what GPT Cache will do for you is, if I have a prompt, and I prompt that over and over and over again, it's the same prompt, I will cache the results of that prompt, and I will be able to give you the right, I'll be able to return you a result almost instantaneously, rather than sending it to a third-party API or running it through another open source LLM. The semantic cache in this particular instance uses similarity search. Again, it uses vectors to determine whether or not two prompts are close to each other, and that will tell me whether or not I've hit my cache or whether I've missed and I should go to my LLM. So again, I won't dive too deep into GPT Cache here. It's not exactly what this talk is about, but I'm happy to chat more about that with anybody if you have questions at the end of this talk. Beyond generative AI, right? And this is a slide that, again, hopefully I've excited you enough about vector search, about vector databases with my previous couple of sections. But vector databases are useful beyond just LLMs. They're useful beyond just retrieval augmented generation. And before 2021, we've seen a lot of these applications as well, and we've really seen these come to the forefront now that LLMs are popular. And I won't go over all of these, but a couple ones that I'd like to highlight are video similarity search, right? If I'm looking through videos on YouTube or on TikTok, I want to be able to search by the content of the video and not necessarily just purely by the creator. Molecular similarity search is another big one. Molecular structures are pieces of unstructured data that is not human-generated. They are not text, they are not images, and they are not videos, but we see a lot of applications of molecular similarity search as a part of the Milvus community anyway. Recommender systems, at the bottom row and the middle right there, the capability to, let's say, have user profiles, have products or any other UGC, and to be able to recommend new pieces of products, new UGC to my user, is another powerful way to use a vector database. And anomaly detection as well, fraud detection, right? You can imagine if I have if I have many examples of fraud and I have many examples of non-fraudulent transactions, I want to be able to search, do nearest neighbor search, and see, hey, potentially which new transactions are potentially fraudulent or non-fraudulent. So coming up on the end of my talk here today, again, I am from Zilliz. We are the company behind Milvus, and I really, really encourage everybody to start playing around with vector search. Do your own thing with vector database. Build your own retrieval augmented generation application. You can do that for free at zilliz.com/cloud. We have a free tier. Or you could download Milvus as well. Milvus is fully open source. And if you want to catch up with me a little bit later, or any of the other amazing members of our team, we are at booth 101, just in the corner, at the over in the exhibition hall over there, and we'd love to chat about everything related to vector search.